Hello, welcome back to Algebra. Here we're going to tackle the last major topic in this unit of algebra, and that's the concept of adding and subtracting these rational expressions or rational functions. So some people say, well, why do we learn how to multiply and divide these rational expressions, which is what we did in the last couple lessons? Why do we do that first before adding and subtracting? I mean, after all, isn't adding and subtracting easier? Well, the truth is, actually, in real life, when it comes to fractions, adding and subtracting is more difficult than just multiplying and dividing. Because if you remember, when we multiplied and divided any fractions or rational expressions, we just multiplied the numerators to get the answer numerator, and then multiplied the denominators to get the answer denominator. And that was it, right? But when we add or subtract fractions, we can't just add them. We have to make sure something is correct before we do that. And that is, we have to make sure we have a common denominator. Basically, we learned this in fractions a long time ago. You cannot add fractions together or subtract them unless you have the same denominator in all of the fractions you're adding or subtracting. And then if you don't have a common denominator, then you have to actually manipulate everything to get the same denominator before you can do anything. So basically you have another step. Before you can add or subtract anything, you have to get a common denominator. So what we're going to do is start off by working some fraction problems. Because these rational expressions end up becoming fraction problems. By the end of the lesson, you'll be adding and subtracting rational expressions with no problem. But first, come on here down memory lane and let's remember how to do things like this. 5 over 16, that's a fraction, minus 12 over 16, and then we add to that 3 over 16. Now in this case, we have 16, 16, 16, all of them are the same denominator, so in this case it's very simple. The answer is just going to be the same exact denominator, 16. But for the numerator, we have to add or subtract. Now we have a 5, we have a minus, then we have a 12, then we have a plus, then we have a 3. So we just go left to right. 5 minus 12 plus 3. And you all know that 5 minus 12 is negative 7. Then we have the plus 3 still here, and we have 16. Negative 7 plus 3 is going to be, what do you have? Negative 4 over 16, right? Now, negative 4 over 16, I guess you could leave it like that, but we don't like to do that. We like to simplify things. 4 divided by 4 is 1. 16 divided by 4 is 4. So the answer that we really have is negative 1/4. Another way you can think of it is divide the top by 4, divide the bottom by 4. This is what you get. We still have a negative answer there. So this is adding and subtracting some fractions. Now the reason we're starting with this is because we're going to ease into algebraic expressions, these things called rational expressions. So for the next one, let's increase the complexity a little bit. In this case, the denominators were already the same thing, but here, let's make that not the case. Let's say we have 1/2 minus 3 over 7 plus 5 over 14. How do we add these? Well, we can't just add them. We can't add the 1 minus 3 plus 5 because the denominators are all the same. So the way I teach people to do this is you have to make each one of these fractions have the same denominator. Now, the thing about fractions that you all know is that you can multiply or divide a fraction by anything you want as long as you do it to the numerator and to the denominator. That way you keep the fraction balanced, right? You can multiply by 100 if you want, as long as you do it in the numerator and in the denominator. So what I need to do is I'm going to take this fraction 1/2. I'm going to subtract this fraction 3/7, and I'm going to add this fraction 5/14. But I'm making the fraction bar longer because what I want to do is I want to figure out, I want a common denominator. I know 2 times 7 is 14, and I know 7 times 2 is 14, and I have a 14 here. So I can multiply this fraction by 7 as long as I do it to the top and the bottom. And I can multiply this fraction by 2 as long as I do it to the top and the bottom. The reason I'm doing that is that will give me a new fraction with 14 for all of the bottoms. Then I can then add them. So that transforms the fractions. 1 times 7 is 7/14, minus 3 times 2 is 6/14, and then plus the 5/14. Now this problem becomes exactly what I did in the previous problem. I can just add them. The answers are going to be over 14. Keep the common denominator, I'll have 7 minus the 6 plus the 5. And then the 7 minus the 6 is going to give me 7 minus 6 is 1, so you have 1 plus 5 over 14. And so what you will have is 6 over 14. Now you might say you're done, but we all want to simplify fractions, right? So let's make 6/14. How do we simplify that? Well, we can divide top and bottom by anything we want. Let's divide by 2. 6 divided by 2 is 3. 14 divided by 2 is 7. So the answer is 3/7. So 3/7 is exactly the same fraction as 6/14, which is exactly the same as all of this, which is exactly the same as all of this if you were to add or subtract all of these. Now the reason we're doing this, and I have one more, is because when we get to the rational expressions, we're going to be having to find common denominators to add them or subtract them. But the denominators won't be numbers, they'll be algebra expressions. And so you have to know what the point of it is. You have to get the denominator the same. Otherwise you can't add anything. All right, let's do one more real quick to solidify the basic concept. Let's do 5/12 plus 5/18 minus 5/36. And I cannot add them because I need them to be all the same. I need them to be all the same. But what I notice is that 12 times 3 is 36. I already have that here. And if I think about it enough, 18 times 2 is also 36. So it's very easy to get a common denominator of 36. How will I do it? Well, I'll take this 5/12 fraction, and then I'll take this 5/18 fraction, and then I will take this 5/36 fraction, and I have to what I call beat it into shape. I have to make it such that I can do this. I will multiply this by 3, and then I have to multiply the top of that one by 3. Then I'll multiply this one by 2, and multiply this one by 2, so I'll have 36 for all 3 of these denominators. Right, so what I will get, 5 times 3 in the numerator there is 15/36. Plus 5 times 2 is 10/36. And then minus the 5/36. Now the answer, since the denominator is 36, will just be 36. And I'll have 15 plus 10 minus the 5. And what I'm going to get here, 15 plus 5 is going to be 25 minus 5 over 36. 25 minus 5 is 20 over 36. Right, 20 over 36. So I'm going to go ahead and say 20/36. Now I'm going to divide the top and bottom by something to try to simplify. I can write it with a dividing by 2 or dividing by whatever I think works. What I'm going to do, because I'm not sure what to do right away, is I'm going to first divide the top. I'm going to divide top and bottom by 4. 20 divided by 4 is 5. Whoops, that's a bad 5. Sorry about that. 20 divided by 4 is 5. 36 divided by 4 is 9. Right? So that's terrible. Let me write that again. Divide by 4, I'm going to get 5. Divide by 4, I'm going to get 9. So the answer is 5/9. Double check myself. The answer is 5/9. That's correct. All right, again, this was kind of a review. Why? Because we're basically adding and subtracting fractions. Yeah, we call it rational expressions, but really we're adding and subtracting these crazy looking algebraic fractions. So let's go ahead and do the first one, and we're going to have to find a common denominator in order to get anything done. All right, so let's go on to the next board. Have a clean slate and do our first real problem. What if we have the expression t plus 2 over 3 plus t minus 4 over 6. So now we have two fractions. They have different denominators, so we cannot just add them. But we have algebraic numerators, so we can't just really add them. But we're going to do the exact same thing. We have to get a common denominator. We know that 3 times 2 is 6, so the way we're going to do it is we'll say t plus 2 over 3 plus t minus 4 over 6. How are we going to get that common denominator? Well, we know that 3 times 2 is 6, so I'm going to multiply this times 2. Now, when I multiply the top by 2, I have to be careful. I have to wrap the whole thing in parentheses, times 2, because when I multiply the top by 2, I'm multiplying the whole thing times 2. Not, if I don't put parentheses, it'll look like 2 times 2 is 4. I won't be multiplying by everything. I need to multiply by the entire thing, so wrap it in parentheses here. So in our next step, what I'm going to get, I'm trying to think of the best way to write it down, is, let's just do it like this. 2 in the front of t plus 2 over 6 plus t minus 4 over 6. Now I have a common denominator. So what do I do next? Let's distribute this in. 2t plus 4 over 6 plus t minus 4 over 6. All I did was multiply the 2's in. Now the answer is going to be over 6. I add the numerators. I have 2t plus 4, that's the first numerator. Add to that the second one, t minus 4. All right, so then when I do this, I say, well, I have a 2t and a t, but then the 4 adds with negative 4, and that gives me 0. So if I really want to strike through it, I can. I don't have to, but the 4 and the negative 4 basically go away. So the 2t plus the t is going to give me 3 times t over 6. And then finally, I can divide the top by 3, getting rid of it. The bottom by 3 will give me 2. So the answer is going to be t over 2. And that's the final answer, t over 2. That's correct. So I tried to pick this first problem to be probably the simplest type of adding rational expressions together that I could come up with, such that you still had to do some work. Because when we get into it more, the expressions will become much more complicated. But the gist of what I have here on the board is everything you need to know. If your denominators don't match, you have to just do some multiplication to make them match. When you do the multiplication, you have to be careful to do distribution as necessary, and then add them, and then simplify and all that. That's the cornerstone of everything that we're going to be doing. Now the next one is slightly more complicated, but very easy to understand. What if you have z minus 1 over z? And you're going to add to that z plus 1 over z squared. Now a lot of students will look at this and say, no problem, I'll just add these together. I got z and z, I'll just add them, got a common denominator. But z is different than z squared. When you find a common denominator, the denominators of the fractions have to match exactly. The variables have to be the same. The exponents have to be the same. Everything has to be the same. Otherwise, you can't do it. So you have to make them the same. So how am I going to do that? Well, let me rewrite it like I do for all of these things. Z minus 1, I'll draw a long fraction bar, z on the bottom here, plus z plus 1 over z squared. Now in this case, I know that if I multiply this by z on the bottom, then what will I get for a new denominator? I'll have z squared. Then I'll match the denominator as I have it over here. But if I multiply this, then I have to multiply the top. But I have to be careful. Wrap it in parentheses times z, because if I don't do that, I'll just multiply the 1 by the z, and I don't want to do that. I want to multiply the entire numerator by z, so you have to wrap it in parentheses. So what you'll do, multiplying and distributing this in, will be z squared minus z. You just take and multiply this and then times this. On the bottom, z times z is z squared. And then I have plus z plus 1 over z squared. Now I have a common denominator. These fractions, or I guess I should say, this one here is exactly equivalent to this one. It doesn't look like it is, but it is. Just like 1/2 is the same as 5/10. This fraction is the same as this one mathematically, even though they look a little different. So now the answer, let me switch colors. The answer will be the same common denominator. I don't add those, just like with regular denominators, the common denominator sticks around in the final answer. And then I just add them together because I have a plus sign. So I have z squared minus z plus, because of the plus sign, z plus 1. Z plus 1, and I'll extend my fraction bar. Then I notice I have a negative z added to a positive z, so actually these are going to add to 0. So what I'm going to get in my final answer is z squared plus the 1 from the end over z squared. And of course you try to simplify it more if you can, but you can't. That's it. Because this is not a difference of 2 squares. This is an addition. So I can't factor this anymore. And also I can't cancel. A lot of students will try to cancel these, but you can't. Why? Because it's linked. It's like there's a chain between this and this. This is a term linked by a plus sign. You can only cancel things if you have a term multiplied by something and a term multiplied by something, and then you have a common thing you could cancel. But here, this is wrapped up inside of this term linked by a plus sign. It's kind of like, it's like that z squared on the top is inside of a box, and I can't cancel it because it's inside the box linked up with the plus 1, right? So I cannot cancel these. I'm done. I can't do anything. I'm finished. So the key here is you had to find this common denominator. Now we have one more question in this lesson. Same sort of thing. We have to get a common denominator. What if we had t minus 4 over 2 times t minus t minus 6 over 3 times t? So same thing. How do I make these a common denominator? Now in the previous cases it was a little easier. Why? Because one of these was a z squared. This one I could just multiply one of these fractions by z and I would get the answer. When I did this one, I could just multiply one of these fractions by something and get the same denominator as over here. But here, there's no way that I can multiply this by something to get 3t very easily without using decimals. And there's nothing I can just do to one fraction or the other. So if you can't just easily multiply one fraction or the other by something, then you have to multiply both fractions by something. So a good example of that back in basic math would be something like 1/2 plus 1/3. You see what I mean? I can't just mess around with the first fraction to get a 3, and I can't just multiply the second fraction to get a 3. The way I do this is I have the 1/2 and I have the 1/3. So how do I do it? I think, well, okay, if I multiply this one times 3, that'll give me 6. Then I multiply this one times 2, that'll give me 6. But if I do that, I have to multiply the top by 3 and the bottom and the top by 2. I have to multiply top and bottom by the same thing. But you see, I can multiply this and get 6, and I can multiply this and get a 6. Now I have a common denominator. So in the same way, I have to manipulate both of these fractions to get anywhere. So what I'm going to have is t minus 4 over 2t minus t minus 6 over 3t. How do I get there? Well, I just use the same numbers, so it's a little bit easier to visualize for this problem. I'm going to multiply this by 3. But when I do this, I'm going to have to multiply the top by 3, and I'm going to wrap it in parentheses so I make sure I not screw anything up with the multiplication. This one, I'm going to multiply by 2. But then when I do that, I have to wrap this in parentheses and multiply by 2. Why am I doing that? Because this will be 6t, and this will be 6t. It is absolutely fine for a common denominator to have variables in it. No problem. But the two denominators must match 100%, otherwise you can't do anything as far as adding them goes or subtracting them. And you didn't have to mess around with any of this stuff when we were multiplying or dividing them, so that's why we didn't have this when we were doing the last lessons. So now that we have this, we continue along. We're going to multiply this numerator out. What do we get? 3 times 3 is 3 times t. 4 times 3 is 12. We have a minus sign, so it's negative 12. On the bottom, we'll have 6t. Then we have a minus sign. Here, 2 times t is 2t minus 12, multiplying and distributing in. And then over here, we get, again, 6t. Now, if I just gave you this problem just like this, you'd say, okay, sure, I can add those together. I got a common denominator, no problem. I'll just use 6t as the common denominator, and that's correct. But when I give it to you like this, you have to manipulate them in such a way that you can get a common denominator. Now, here's the secret. A lot of students struggle with, well, what's the right denominator? Which one should I pick? Well, the truth is, it doesn't matter. It doesn't matter what common denominator you use. In this case, I did it this way, but I could have picked some other common denominator. As long as I can beat those fractions into having the same common denominator, I will always get the same answer. Because if I use a different common denominator, I'll get a different numerator also. Then I'll be able to simplify that down, and I will get exactly the same answer as we're going to get right here. Now, here's what we got to do to be really careful. I need to be really, really careful with you so that we don't make any mistakes. In the previous lesson, in the previous problem, I should say, there's a gotcha here I need to make sure you're aware of. We got to this step. We said this z squared minus z plus z plus 1. So we just wrote it out straight away. Because there was a plus sign between the fractions, it was very simple to do. We just had plus and then this. Let me show you how you're going to go wrong if you make the most common mistake you can make here. The answer is going to be over 6t. That's true. Most students will do this. 3 times t minus 12. They'll take the minus sign from here, 2t minus 12. And then they're going to get the wrong answer. Can you spot the mistake? Can you see what we did wrong? Well, what's going on here is you can kind of envision this numerator here to have an invisible set of parentheses around it. All numerators of fractions are kind of invisible here. So when we subtract this guy, what we're doing is we're subtracting the 2t, that's right, but we're also subtracting the negative. What happens when you have a subtraction of a negative 12? You're subtracting a negative. You're having two negatives next to one another, which make it a positive. So when you think about it, this, if it was negative 1 out here, you distribute in, you get a negative 2. You distribute here, you should get a positive 12. But here we wrote a negative 12 because we were careless. So we have to, when we're subtracting these things, we have to distribute the negative in. So this becomes a plus 12, right? Because what you're doing is you're saying this minus this quantity means we're minusing the 2t, we're minusing what this is, but it's minus minus makes it plus 12. And you're just going to have to be careful when you're subtracting to make sure you're distributing it in properly. All right, now what do we have? We have 3t minus 2t is going to give you t. We have a negative 12 and a positive 12, so it disappears completely. On the bottom, we'll have a 6t. And so then when you have t over 6t, the t's are going to cancel, and you're just going to have 1/6. And that's the answer, 1/6. So again, Doesn't look too bad, but there's a lot of places to make mistakes. You can multiply this by anything you want and this by anything you want, as long as you do it to the tops and the bottoms with the goal of getting the same denominator, right? In this case, we pick 6 because I know that 2 times 3 is 6, and that's going to be easy, right? But I could also pick 30 if I wanted to. Honestly, 30 would be a common denominator. Why? Because 2 times 15 will make 30. And 3 times 10 will also make 30. So if I multiplied this by 15 over 15, and then multiply this by 10 over 10, I would still have 30t as a common denominator. But when I do that, the numerators will be completely different because I'm multiplying by different numbers. And when I go through all of it, I'm still going to get 1/6. Just like when you add fractions, I can use any common denominator I like, and I can still get the exact same thing. In fact, I mean, why not? Just for giggles, let's go over here and do it again. Everybody in the universe is going to use 6 as your common denominator, but let's not do that. Let's say 1/2 plus 1/3. Okay, let's use, like we said, 30. Let's say we're going to multiply this by 15, which means we multiply this by 15. And we'll multiply this by 10, multiply this by 10. Everything's legal. On the top, we have 15 30ths. Over here, we have 10 30ths. Now, what are we going to get here? We have 30 as a common denominator, so that'll be our common denominator. And then here, we'll get 25. So we have 25 30ths. We know we can simplify that. 25 divided by 5 is 5. 30 divided by 5 is 6. So the answer to this guy is 5/6. That's the answer we got. Now if we went back above and worked it out with the other common denominator we were using, what would we have gotten? We get a 3 here, 3/6, plus this is 2/6, and that's 5/6. So you see, if I choose the easiest common denominator, what we call the least common denominator, we'll have the least amount of simplifications to do to get to the answer. But I can choose any other common denominator I want, and I'll end up simplifying the answer back to the same thing. Same thing is true with these algebraic type of rational expressions when we add them. Use any common denominator you want to, but at the end of the day, it'll be able to be simplified down to the one and only correct answer, in this case 1/6. So make sure you can solve this, every one of these problems, solve them yourself. Blank sheet of paper. Follow me on to the next lesson where we will go through increasing the complexity of these problems step by step.